everyone, welcome back to our YouTube channel. I am Desire, and today we've got Matthew who has just completed the course ROS2 Basics in 5 days using Python, and he'll be giving us a presentation on that. So first of all, what we'll do is we'll first begin by seeing a demonstration of his code running on the real robot, and then we'll get him to present and explain to us what he did, and then towards the end we'll get to ask him a couple of questions to really get to understand what he did and how he did it. So I'll now hand over the platform to him so that he can begin his presentation. Alright, whenever you're ready, Matthew.
Hi, good morning. My name is Matthew Martin. I completed this class. It is now time for the demo. Part of this is unfortunately requiring to get the real robot positioned right. The program is meant to be a wall follower, but it needs the wall in a certain orientation relative to itself or it won't function properly. And the one notable disadvantage about the real robot is it doesn't start in the same place every time. So sometimes you're required to fiddle around with it and be like, oh, I need it turned this way, I need it turned that way, I need it to do this. Let's see if that position makes it work properly, and it's main.launch.py. So let's to launch wall follower main.launch.py. If all goes well, it should.
And
actually, that's weird. It is, in fact, not launching the service that it should be.
maybe change where it starts. Let's
file.
have it start on the pedestrian crossing so that so that we can see if it can follow the wall first before it runs into obstacles.
The intended functionality, which I'm a little confused by this isn't exhibiting as I got it working in simulation before this presentation, is that it begins from a position and then looks to the wall to its left and then travels to the wall until it's a set distance away. I think it's supposed to be 0.35 meters, something like that.
Between 0.2 and 0.3, yeah.
Oh gosh. This is unfortunately very fiddly to actually steer.
You could try using teleop if you're struggling with that one.
Okay. Oh no. I mean, teleop isn't much better, unfortunately. It's just that the little gamepad UI we're given is not very sensitive, so it's very easy to overshoot. Okay. Let's have it go forward. Boom. So, it should be. I'm going to need main.launch.py because otherwise it's not going to boot the Finder and the odometry data files. So, wall follower main.launch.py. Let's see if it actually wants to do the thing. Nope. Okay. Interesting. That's not what it was doing in simulation. So I have no idea why this is happening the way that it is.
Did you try running it? Did you try running it on the real robot before now?
Yeah, I did, and it worked. But that was like last week when I was actually working on this.
Alright.
So
can you try disconnecting and connecting again?
Yeah, I was like, okay, bad goes worse. I can show it off in simulation because at least I know that it works semi-reliably there. Even there, it still will occasionally run into like something weird where it gets tripped up on a corner. But render follow. So I don't need the editor. I need 2 terminals, which needs the XML. Actually, let's just connect to the robot again, see if I can get that to behave.
Mm-hmm.
Bell. Workspace. Build. Install. Setup. Crash. And the ROS2 launch. First, let me try to get the robot out of this corner. There we go. Now back it up. And let's try this again. ROS2 launch. Wall. Following. Or wall. Wall over. Yes. So there's wall. Render interfaces and do wall following. Because I don't need the interfaces. Well, I need the interfaces, but not like that. Main dot launch dot py. Let's see if it actually wants to boot the service properly. Nope.
Is it okay? Is it okay?
The odometry is waiting. It looks like it's not talking properly with the LiDAR because turn is the name I gave to all my stuff that was handling the LiDAR, and it's always just spitting out waiting for scan.
All right, can you try do this in simulation and let's see if it works there. So
yeah,
just disconnect from the robot and try there.
I have zero concern about simulation because I had it working there about 3 minutes before I joined the presentation this morning.
All right.
I don't know why it's not connecting to the LiDAR on the real robot properly.
Okay, what's, oh, you have disconnected already. Can you could try and check to see what topics are being published and all.
True. All the same, I want to show it off working at least once this morning.
Okay.
So this presentation is in a total wash.
Okay.
So there. So that will be launching simulation itself. Terminal. That. Wait for the simulation to finish loading. I should probably open it up. Now we're just waiting on the gazebo simulation to actually boot.
Okay.
Which can take a minute first. I'm yet to do it in a new instance if I'm not mistaken. it is in fact named up. Should be a big thing.
It's taking a little bit of a while.
Yeah, I have half a mind to just restart it.
Yeah, I think you might have to do that.
Oh well, nothing says you're giving a presentation like technical difficulties you haven't run into before.
Yeah, yeah, it does happen.
Hey, there we go. So,
Okay.
here's the robot.
Let's see it from the top.
Unfortunately, I am on trackpad, not on a mouse, and I'm yet to actually figure out the...
You can go on the orange box. On the orange box on the very top. Yeah,
Up.
yeah.
Oh, neat. I'll do the thing.
Yep, that one. Yeah.
Oh, no kidding. That would have been good to know about like 16 hours ago. But also, my fault, my failure. Cool, let's see if it actually talks with the LiDAR. See, so you'll notice the robot is first turning to face the wall, which is doing properly. It gets close enough to the wall, and then turns back to face the original way. Right now, you'll notice in the terminal, it's just like, oh, half clear, moving forwards. This number is the distance from the wall to its left. Here pretty soon, we're going to see it hit a corner. Actually, right now it's performing a bit of code where it's like, oh, the wall to my right is a little bit too close. So I'm going to rotate 90-ish degrees, move a tiny bit, and then face back the way I was going. Which, although slow, was kind of the best way I could get this to work.
It looks like it's running into the wall again.
Oh.
Maybe it's just because the wall is slightly further than the actual track markings. So,
yeah, it's... this is another instance of it behaving kind of strangely.
Alright, there we go. Okay,
it clears corners about half of the time.
Okay.
And by that I meant all of the time when I was doing it earlier, but here we are. So, time to relaunch the sim and start over. Unfortunately, due to the fact that it is slow, it will be very difficult to demonstrate the final bit of functionality, namely when it completes a full loop based on checking, okay, how far away am I from my original position? It will stop and spit out some final goal data. Once again, considering this robot isn't super fast, it'll be difficult to demonstrate that functionality, but I can show in the code where it happens.
Alright, yeah, it'll be good to see that and see what bits and pieces can we iron out.
Yeah. I also wonder if part of the problem is my connection's kind of slow, meaning
well,
the simulation's probably lagging a little bit relative to the code, which is what's causing it to not detect the wall quickly enough.
I wouldn't say that really. I don't think so.
Because...
alright, so...
well, I mean... yeah, it's...
alright, let's...
running into that wall doesn't trigger the corner logic like it was earlier.
Okay, let's go and see where you actually do the wall following behavior, implement that, and how you take in laser scan data and process it.
Yep. So, here we have my node. This is kind of where everything gets initialized. I have an action client that I refer to as my odometry client. That's where I get all my odometry data. And then I also have a interface called find wall interface. I refer to this as just client. I have a timer to get velocity feedback. Here's my laser subscriber, and here's my publisher to twist, which is what allows the robot to move. Here's my stuff waiting for find wall interface, which is
Okay.
Here I am sending requests. That's for the action server and the other thing.
All right. This is
I
for
can't
the
remember right now.
wall following behavior, right? I want to see the wall finder first because I think that's where uh,
Yeah.
things are not happening
So
properly. So
the finder is working perfectly fine because that's what causes it to rotate 90 degrees, go to the wall, and then rotate 90 degrees again.
and leave the
Um,
required space on the left of the robot,
yes.
right? Okay.
Here's basically all of that, and then we get to wall find callback.
Mm-hmm.
I get my min distance, my min angle. Here we go.
Okay. Can you explain to me a little
While
bit how that is happening? So, how is it? Does it make a step towards the wall first if the distance is beyond 0.3 meters? How? What is happening there?
So I'm constantly running a callback which extracts the min angle, which is the angle min. You have to get an actual angle out of it, you have to do angle increment plus the index of the scan.
So okay. So this
So
angle, is that the angle between the front index and the right of the robot? Or
that's the angle between the closest thing that the robot sees,
mm-hmm.
which, when positioned properly, is the wall, and the front index. So, like, straight out the front where the camera is, if I'm not mistaken.
Okay.
This
Alright.
callback takes that data, spins at roughly 5 degrees per second, and then it calculates a time that
Mm-hmm.
it needs to spin,
Mm-hmm.
and
So
then I use a while.
all right. So when it realizes that there is that obstacle, what does it prioritize, putting it on the left or on the right, based on when you're designed for the wall follower? What does it do?
I have it hard-coded that the wall will always be to its left,
Okay.
so it'll spin to the left.
Okay. So it will. Okay.
I have a time minus start time is less than delay time
Okay.
to get it to spin properly, and then I do the same thing. I hard code a linear speed of 0.08 meters per second,
Right.
do the same thing, get it to move closer, and then because I know that it rotated basically 90 degrees to the left, I just arbitrarily get it to rotate 90 degrees to the right, and in all of my testing that ended with it facing the right way.
Okay. So, all right. So you are controlling your angular velocity by using the time that it rotates. So you set an angular velocity,
Yes.
and then you calculate the time that would be required to cover a 90-degree rotation.
Yes,
Okay.
and I manage that by setting start time with time.time,
Uh-huh.
and then while current time minus start time is less than the time I need to wait, I publish message, which is my twist message, whose value I set here.
Okay.
So
Okay.
it does stuff.
All right.
Um,
All right. So this
And then
seems to
here's
be
the response.
yeah. This seems to be working fine. So the wall following is the one that has got issues. Is that right?
Yes,
Yeah.
that's
Okay.
the part that was not tracking corners correctly.
Mm-hmm. Okay.
So, in here, I have a few helper functions for going forward, turning left, and turning right. Going forwards is literally just, okay, wait, or go forward for 0.1 seconds, and then turn. I felt that was an appropriately small unit, and it moved fast enough. For turning left and turning right,
Mm-hmm.
it turns 90 degrees the other way, moves forward a little bit via, actually, no, it just does that, and then moves forward a little bit via go forwards, and then turns back the other way. So, yeah. And then here we get into the velocity callback. This is just me figuring out, okay, where's the wall relative to me? What do I need to do about this? Here's also where I handle the asynchronous server response for determining when it's completed a full loop. That's kind of this whole big block of logic here.
Mm.
Here I extract front, left, and back data points for me to do stuff with. These just get printed to a logger. Here's some logic for my turning state, which is the part that wasn't functioning properly.
Let's get through this one slowly, because I also want to know why is it not working if you said it was working, right? What did you do? Can you explain it step by step?
So I will add the caveat, I have not changed this logic since I tested it 5 minutes before I got on with you, and it turned successfully there, so honestly, I have no idea.
Okay.
So there is an internal boolean, self.turning, and if its turn counter is less than max turn cycles, then it means it's still kind of turning. I chose to have it just kind of do an increment thing, mostly as a debug, so I could tell the difference between, oh, it's just turning right because it's too close to the wall, and oh, it's actually turning.
And your cycles, how do you determine the maximum number of cycles?
That's arbitrarily set as a variable. I chose 5 because in my testing that worked best. But see, self.max turn cycles is 5. That also works based off of the angular velocity I chose, which is 0.25 if I'm not mistaken. So, I guess 0.3.
Okay, so the max cycles is that the amount of times that the call to 10 will be called by your callback? Is that right? Or if I'm getting...
Yeah, basically. It'll get down to here and be like, oh, if self.turning, if turn counter is less than that, then it does this logic, which is it actually turning a little bit.
Okay.
But if it's already hit the max number of turn cycles, so if this evaluates to false, then self.turning gets set to false, so the turn counter gets back to 0, and I publish an empty twist to get it to stop.
Alright, so there seem to be no way of really controlling how much it turns, right? Because what if it turns beyond what you actually, beyond the angle that you want it to turn, and the number of cycles has not been, is not reached 5? What happens?
So, in my experimentation, that didn't really happen. It was able to recover fairly robustly by just turning back towards the right.
Okay.
If that didn't happen, actually, I didn't run into any cases where that didn't really happen.
Okay. Because I'm also thinking probably maybe that's where the issue is coming from. But well, this is an assumption. You would know better because of the way you implemented it, right? But I'm thinking that might bring up issues because it's like an open loop kind of control, right? So
yeah, part of the problem, at least as I interpret it, based on my terminal output, specifically with this execution, is it was not updating quickly enough. That being, the information from the simulation was not being processed quickly enough.
Okay.
To the point where the robot would crash into the wall.
Before...
It would keep spinning for a couple seconds.
Alright.
And then the terminal would print the output, oh, corner detected, I'm starting to turn.
Okay.
When in some of my previous executions, it was able to detect that properly. I don't know what's up with that delay.
Okay, I see
Your
what
guess
you mean.
is as good as mine.
Yeah. I understand what you mean, yeah.
Getting into, here's the very basic corner detection. If front is less than this threshold and left is greater than this threshold, I'm like, I needed a way to differentiate needing to make a 90-degree turn from just, oh, move slightly right.
Right.
So that's why the front criteria was added. This just sets turning to true and turn counter to 0. And then on the next time through, it'll just hit this block of logic, do the turning, and then return. And then now that it's turned, this won't evaluate to true anymore, meaning it'll just keep going back down.
All right.
If left...
Okay, go ahead. I think you've got about a minute left now, so...
Yeah, I'll try to burn through this. If left is greater than 0.35, it turns 90 degrees left, goes slightly, turns 90 degrees right. Vice versa for being too close. Here it is, just going straight. Else, this is the debug message I was getting a bunch with the robot of waiting for scan. This indicated to me in that instance that the LiDAR scanner was not working. or not properly talking with my ROS program because it wasn't getting any data, which explains why it wasn't doing anything.
Okay. I see.
Here's my publisher. Here's laser scan callback. Basically, all this does is it pulls the closest point in these ranges. I only end up using actually mostly left, and I combine front left and front right into one data point elsewhere, but I also extract front right, left right, and back data, meaning I could make this a more robust or bigger thing if I wanted to. Here's my main, where I boot everything. I start a multi-threaded executor so I can get all of my callbacks to function at the same time. It took me a while to figure out how to do properly.
All right.
And here's my logic for the action server and the other thing whose name is currently escaping me. All the same. I also have an exception for keyboard interrupt because before I added that, it would just hang forever and it was really annoying.
Okay. All right.
Just clean up, and there's the end of that.
All right. Thank you very much, Matthew. All right. So just hang on. We will wrap it up here, and then we'll finish our conversation on Zoom. Okay.
Yep.
All right. All right, everyone. This was Matthew's presentation, and I would like to encourage all those of you who would like to come and make their presentation and showcase their work to do so. And until next time, we encourage you to keep